Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which converts a binary tree into doubly linked list in spiral fashion. First, let us take an example. As you can see, we have printed the elements of this tree in a spiral fashion. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node to function spiral level order. So, root will point to 1 and we push 1 into a DQ. Also, we create a stack to store binary tree nodes. We take a level variable and initialize it to 0. Now, as the queue is not empty, we enter the while loop and take another variable node count which stores the number of nodes at current level. Now we check if level is odd or even. Since level is 0, we take it as even level and go to the else part. Now as node count is greater than 0, we enter the while loop in the else part. Next, we DQ node from back of the queue and push it into the stack. So, node will point to 1 and 1 will be DQ'd. Now we will push 1 into the stack. Next, we insert nodes right and left child in the queue. So, first we insert the right child of 1 at front of the queue. And now, we insert the left child of 1 at the front of the DQ. Next, we decrement node count, so it will now be 0. As node count is not greater than 0, we come out of the inner while loop and increment level. We continue with the outer while loop as the queue is not empty. Now, node count will be equal to 2 as there are 2 elements in the queue. Now, as it is an odd level, the first if condition gets satisfied and now as node count is greater than 0, we DQ node from front and push it in stack. So node will point to 2. 2 will be DQ'd. Next, we push 2 into the stack. Now we will insert its left and right children at back of the DQ. So 4 and 5 will be enqueued. Next, we decrement node count. As node count is greater than 0, we continue with the inner while loop and pop the node from the front. So node will point to 3 and 3 will be popped. Next, we push 3 into the stack. Now we insert the left and right children of 3 into the queue. So 6 and 7 will be enqueued. We decrement node count. This time node count is not greater than 0, so we come out of the inner while loop and increment level. As the queue is not empty, node count will be equal to 4 as there are 4 elements in the queue. Now 2 is an even level, so we go to the else part. As node count is greater than 0, we DQ a node from the back of the queue. So node will point to 7 and 7 will be DQ'd. Next, we push 7 into the stack. As 7 does not have left and right child, we decrement node count. Since node count is greater than 0, we continue with the while loop and now node will point to 6 and 6 will be DQ'd and pushed into the stack. As 6 does not have any children, nothing will be enqueued and we decrement node count. Node count is greater than 0, so we continue with the while loop. Now node will point to 5 and 5 will be DQ'd and pushed into the stack. As 5 does not have any children, nothing is enqueued and we decrement node count. Since node count is greater than 0, we DQ node 4 from the queue and push it into the stack. We decrement node count. As node count is not greater than 0, we come out of the inner while loop, and now as the queue is empty, we come out of the outer while loop as well. We take a head pointer and point it to null. Now we will pop all the nodes from the stack one by one and push them in the beginning of the list. Note that we are assuming that the function for creation of the doubly linked list is already there and we are passing elements for the list. So, after popping each element one by one, we will have the final doubly linked list. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.